Hi everybody, I want to welcome you to my YouTube channel. This is Steve from C64 Brain, and I appreciate if you go ahead and click the notification bell, and also I appreciate your comments, and most importantly, all the projects and interaction will take place on the Facebook page, so meet me up there. Okay, so in this series, what you're going to learn about is finally seeing video 1, where we're going to explore how to bank memory on the Commodore 64 at the project, and from there we're going to be able to copy character set that is actually stored in our map to memory. In order to be able to reserve more graphics for the computer itself, we're also going to relocate memory from ROM, basically make it rewritable into RAM. And then finally, we're going to be able to get the map displayed on the screen. And you're going to see examples all throughout this. Hello everybody, I'd like to welcome you to the Commodore 64 game project video 1 for C64 Brain. We are finally ready to do this. Learning to write in assembly language. For the record, the purpose of this video series is not to teach you how to write in assembly language, as that would be way more time consuming. Rather, it has been created to give you an inside peek at how your Commodore computer works from a memory perspective so that you can start creating your own masterpiece projects. Therefore, if you are totally new to learning assembly language, then I highly suggest finding a good book or website. Spend time learning how to put together small functions, learn how the memory map works, get a grasp on binary bits, and experiment to see what you can come up with. Hopefully, following these things will allow you to keep pace with this series, as it will start with a small set of files and begin to get larger with each new video release. Wishing you the best of luck. And don't forget, as always, to subscribe to my YouTube channel, and my Facebook link is below and I'll put it in the description. Project code downloads. Finally, each game project will utilize Github for repository saves so you can download and learn from the code. Note, it will be necessary to have your own GitHub account to access the files, and of course this is just a GitHub section. Hi everybody, I want to thank you for joining me today. In this series, I am going to demonstrate how to use video 1, the project that are included here, to be able to go ahead and, first of all, get it from GitHub. And then once we get it from GitHub, we're going to go into the project itself, and we're going to basically load the project in by opening up the project, and then we're going to be able to go ahead and tweak it and kind of make it our own. So you should be joining me at GitHub. This is where I stored all the actual projects here. This is all for video 1, and you'll see all of them all the way up to project 18 and so on. They'll all be here. So first you'll see scene 1, scene 2, scene 3. These are just the breakdowns from the first video, which demonstrates the progression stages of the project at that time. And of course, we're going to be using scene 3 here. So if you go to scene 3 here, this is going to include all the files you need for video 1. The first one here is actually the zip file. So you can just go ahead and click on it here, the CBM-PRG Studio zip file. And then over here on the right, you're going to click on the download button, and you'll see a download here in the corner. What will be learned in video 1? The goal of this project is to give you a set of tools to create your own games and projects. In this lesson, you will gain the following skills: a knowledge of how the Commodore computer graphics memory work. You will learn how to switch banks and relocate memory where graphics can be stored. Explore how a character set exists and can be rewritten for your own use. That's copy chars. The tool character CharPad allows us to create a sample map that can be loaded in memory. Utilizing 4K of bit area between D000 to DFFF to access multicolored graphics and foreground background screen controls. Loading the CharPad map using the subroutine load level and draw map. And here's a project 1 flowchart I created for this series, so you can see we're starting with copying the characters first, and then we're going to load the level, draw the map, draw the tile, and then finally we're going to place them on the screen with the get screen line address. Before anything, we use the commands incasm, the vic_registers.asm to connect the vic registers to our project, and the command incasm game macros asm to connect the macros to our project. And you'll see an example of this soon. Now here's our first file, vic_registers.asm. I'm not going to go over all these, but these are just those memory controls that you can use to get your sprites on the screen, your colors, and all that kind of stuff. And here's our next one. This is game macros.asm. Again, I'm not going to go into full explanation, but these are here from load pointer to copy pointer to add pointer, save reg, and restore reg. And these are going to be in place to make things easier as we're going through the program. You'll see them as we go throughout the series. The next one, this is the main file, main.asm. And here you can see I listed a set of the project variables. And I won't go over all of them, but we're going to be utilizing mostly screen mem, color mem, character underscore mem, level 1 map, level 1 characters. Those are going to be very primarily used throughout this project. And down below you'll see 0-page labels that are going to be used throughout the project. And here's the 0-page pointers. And the one you see map X pos and map Y position, those are going to be used for drawing our map and positioning on the screen. Now, the first thing it does in the program is it starts a basic kickstart loader. I won't go into a lot of detail, but it's basically just a way of creating this sys2064 or whatever it is that's going to actually allow, I'm sorry, 62049, as I demonstrated there or whatever, that's going to allow you to get your Vice emulator running the project real time so you don't have to sit there and type sys and run it. Relocating video memory. When the computer is first turned on, the memory defaults are set up specifically for basic allocation. However, this leaves little room to add more sprites and graphics data. Therefore, since the VIC-2 chip can see only 16K of memory at a time, it is necessary to create more space when designing a large map and needing a lot of sprites, character set data, and so on. Below is some sample code that will take time to explain. This is called banking video memory, and it's the best method when you want to build a much larger project. In this video, I will also be switching back and forth between code examples and providing more in-depth explanations. Set VIC 16K memory to bank 1. The example seen below is using bank 1, DD00, which is 56 by 76. And is perfect for us since there is an extra 8K that can be reserved for sprites and character data, which is 2K. And I put and removes bits or restores bits. And there's the example of our first banking. Now the next one here is an inside look at VIC-2's memory, and I highlighted the one we're using there, bank 1, but you can see there's also bank 0, bank 2, and bank 3, and these are exactly what you can do with these areas. And that's the chip display down below. For those who may need a clearer picture of what is going on, I have extracted a diagram I found in the book Compute's Reference Guide to Commodore 64 Graphics. By looking at each image, you can hopefully understand how the VIC-2 can set memory as follows. Highlighted below is the one in use. And you can see the one we're using is bank 1, which is memory registers 4000 hex to 7FFF. Here's a visual of the VIC-2 CIA memory. Each slot is limited to 16K of memory starting at the lowest bits to the highest. For bank 1 that we'll be using, the character generated ROM must be moved so we can alter it. 2K of this memory can be used for character graphics, if allowed. Sprite data can be placed in any of 256 groups of 64 bytes each. Finally, text screen memory can occupy any of the 16K areas. And here's a basic example of bank switching I found. Below is a program I found in the Compute's Reference Guide to Commodore 64 Graphics that demonstrates how to view a character set stored in ROM memory without copying it to RAM. Hopefully this will help you understand where the character set that makes up the letters, numbers, and symbols that can be entered from the keyboard exist at in memory. And you can go ahead and leave this. I'll include this in the GitHub project. An example of bit masking. When the Vice C64 emulator first loads, the registers are set by default to bank 0. To learn about how banking works, I am providing a simple example so you can see the bits as they are translated. The example below takes the number 151, reserves bits 0 to 1, and masks out, removes bits 2 to 7 in total. This is known as bitwise and/or. Bit masking is necessary to keep specific bits while discarding the others. A common example seen in games is turning off certain sprites after the player kills them while keeping the other sprites enabled on the screen. The example below is used to switch from bank 0 to bank 1 with register CIA number 2. So there wasn't enough room to also demonstrate the OR example here, so it's divided into two parts. on the next screen. And you see the top line there represents the bits going from 0 to 7. And below that would be the value of 151 translated as binary. And then you see the AND example there. That's using from our code example you saw earlier. And the result is what's down below. Now here's the rest of it. It also does masking of OR, so it can basically turn on the bits that it needs. As long as a 1 exists with OR, that bit will be 1. Otherwise, it will have a 0 result. And you can see I put bits again there, and the result left after the first AND. I left that calculation there, and then I show the OR and the final results after clearing and setting of bits, assuming this is correct. Okay, I'm now going to demonstrate how to load Scene 1 into your project. Remember, you can download this from the GitHub site. Once you have it downloaded, you can just simply go ahead and go to File. And then what we're going to do is we're going to open up the project since we saved it as a zip and unzipped it. And then we're going to go ahead and locate that folder for our project, which I stored mine under here. And you'll see Scene 1 is right here. Click on it. And all you have to do is click on the CBM PRG Studio link there. And it'll open up the project for us so we can go ahead and run it. That's simple. The first example you see here is bank 1 memory. There's no screen yet since we haven't copied character data over yet. Copy map to memory for later. In this next example, we will read the value from proc port register 0 and save it. Then we switch out basic kernel Kernal IO and save the result in proc port. This was originally written this way to save the map tiles so that they can be restored later when the game resets. Although we may not see this happen in this project series unless we decide to create a new level. And I'm not going to read all this, but this again is just showing the code example below, which we'll demonstrate soon. Next, we use some macros to reduce repetitive code. The macro load pointer below utilizes the load save techniques common with LDA and STA. Macros are found in the file gamemacros.asm that we reviewed earlier briefly. And again, this is just the example of how to use macros. And in this example here, I put when the game starts, level 1 tiles and characters are stored in place to run. However, when the game resets, we would need to restore these levels intact. So we save them under the kernel at E000 to EFFF, which is 4K. And this is done with bank switching, copying data, restoring and so on. Okay, so mapmem reads from our file here, which is our character pad map file. And level 1 is reading from the ROM memory there. And then down below is our first subroutine, which is JSR copy characters, which copies character data to memory. And I'm going to demonstrate the first banking series here with the CBM PRG Studio project. Okay, now I'm going to demonstrate how to add scene to our project. So make sure CBM PRG Studio is open. We're going to go to File. We're going to go to Open Project. And we're going to locate it, which mine is stored right here. We're going to go to Scene 2, open it, and you'll see the CBM PRG Studio file. Click on it and open. It will load everything we need for the project. You see everything here, and all we have to do is run it. And there we go. The second project doesn't have any data loaded yet. We haven't copied the map over. All we did is we added the game routines, which essentially is copying the character set, but we haven't displayed it yet. Here's how you set up the multicolor screen. Next, get X and Y tile coordinates to be positioned on the map using the subroutines load level and draw map. And we'll do is we'll cut now to show this. Now I'm going to demonstrate how to load Scene 3 in our project. Make sure we have CBM PRG Studio open. After we downloaded the GitHub file, we're going to go to File, Open Project, and we're going to locate the folder where our project is. Mine is here. And you'll see the CBM PRG Studio file here, and we're going to open it. And it loads it in. You'll see all the files here. And all we have to do is run it. And you'll get to see what the result finally looks like. And there we have it. A nice little map taken from Character Pad. Now we focus on fixing a bad line that appears at the bottom of the screen using Vic Screen Control. Set the border color and enable multicolors for our map display. Turn on active screen bit for bad line. And I put that one in there because it actually does fix a bad line. Set Vic to character memory. By default, when Vice, your Commodore computer, is first turned on, the character generator ROM is contained in 2K of memory between D00 to D800, which contains the upper lowercase set. Since we are using Bank 1, VIC2 does not have access to the character generator ROM, read-only memory, so it must be copied into RAM, random access memory, where we can change the data to create our own map. The code below shows how to switch to the character set in memory, and later we will copy it. We use bits 0 to 1, which point to the location of the character.data area. By default, the characters you see on the screen are safely tucked away in ROM even when you turn off your computer. The main loop subroutine is needed to keep the project active and not exiting the BASIC in the Vice C64 emulator. In later projects, subroutines will be looped consistently when the joystick is in use, sprites are moving on the screen, and so on. That'd be like video 2, 3, as we continue to move through them. Load the character set data from CharPad and store it in address 4800. This is used in screen memory.asm later to display tiles on the screen. These are real important because if you look at this right here, these are where and how you're reading binary data from CharPad. In this example, it's reading the map files. Down here, now I won't read all this, but you'll see where it says map memory. That's reading in the map memory from CharPad. The attribute mem is reading in the attribute color memory from CharPad, and the tile mem is reading the tile set data from CharPad. Now we're on to game routines.asm. Now we load our first file. In CBM PRG Studio, this is done using IncASM, game routines.asm. This is obtained after we used our JSR copy cars subroutine. The code below is simply copying the character generator ROM, E000, to RAM memory, so we can change to our new character set. This will then contain our map area that was created in CharPad. Note, code extends to several slides, so I've got this broken down, the first part here, and then here's the second part. At this point, we're going to start copying the map data to memory to utilize it. And here's another rest of the example. These are now copying the high bit, so it's copying 255 characters over from our character set. Now the next one is screen memory.asm. This is used to place CharPad map data in screen memory so it appears on the display. And essentially all this section is doing is just taking these lines and using it to place data on the screen. Looking at the map screen memory. The following routines check for screen 1 or screen 2 and read the screen memory address lines from a table. These come in handy later when a sprite needs to check the area around it, top, bottom, left, and right. So for example, if our map were a simple 1x1 layout and we were standing at screen memory address 1400, the tile underneath it would be 1440. Our map is arranged differently, but I'm hoping that the Vice example makes it easier to understand. Now here are the screen memory tables that's actually allowing you to place that data on the screen. You see a couple lines of them here. These are the low bytes here, and these are the high bytes. And this is the color RAM, high and low bytes, or low and high bytes. Now we're going to load the file startlevel.asm. The code below prepares the screen for the placement of our map from CharPad. It does this by saving screen memory variables that place addresses in them. And now we get ROM character set in memory. Begin loading the character set data from ROM based on the level of the game. And as you looked in the example we saw, you'll see that what this is doing is basically allowing us to place those tiles on the screen. Copy CharPad map to memory. Copy the CharPad chset binary file data and get ROM character set copied to memory. The X register here manages which level of table data we are pointed to for the map. Copies CharPad chset binary file tileset data from address 4800, which is our char_mem variable. Plot out map coordinates, which is our x and y. Copy CharPad data down the screen. First, find the address for the starting map position and begin reading the CharPad map data to the screen from top to bottom. Okay, now we're going to hopefully see a more visual example of how this is working. This section begins the laying of the 4x4 tiles that are used for our game map. If you look at the CharPad example, you will see that they are stacked on top of each other. See the example here. There are 4 tiles going left to right and 4 tiles going top to bottom. Beside it is an example of a tile as seen in the game. So the first example you're seeing here, if you look here carefully, there you want to look that there's 4 tiles in a row here, and there's 4 tiles going down. And down below in the corner there, to the left of it is an example of a smaller tile as it'll look on the screen. Read the first tile line. The add pointer macro is used to read 100 tiles from the CharPad map total length. This line can be changed to fit your exact map. So if you only have a map that is 50 tiles, it can be changed here. Draw 10 tiles side by side across the screen and 5 character tiles, data tiles side by side. These manage what can be currently seen as the map is displayed and scrolled in video 2. Note, the subroutine draw tile is what places them on the screen. The example below contains 4 tiles, so when we reach number 5, we are done. It never gets drawn. And you can see right here, this is 10, so it's basically taking 10 of these and placing them all the way from left to right across the screen. And then down here, 5 is telling you it's reading up to 5, so it's reading 4 tiles, and I demonstrated here from tile 1 to tile 4 as it's placing them on the screen. This is what creates that example that is seen in CharPad. Prepare tiles for the main screen. So here we're just setting up some variables, and I listed what param1, param2, and param3 do for reference. Copy color RAM to memory. Place tiles on the screen. So now we're actually reading from that screen memory ASM file to get in our table data to start placing them down the screen from top to bottom, including the color. Read in CharPad tile data. Fetch the source tile address and copy them to 0-page pointers. And I put an example here what mapmem is doing. It's just pointing to that CharPad map binary file data. Get color attribute data. Loop through and draw the tile. The attribute data from CharPad is also stored here so we can detect other things on the screen like water and so on. So you can use this to detect if you bump into something. And down here you see where it says 15. That means it draws 15 down the screen. Place 4 tiles side by side. By masking out the first 2 bits in the accumulator, and I show an example of it there with the binary, we get a number that counts 0 to 3 over and over without stopping the data fetch 0 to 15. And that's what this is for right here. This is just determining how those tiles are being placed side by side. Continue to place tiles on the screen. When advancing to a new line down in screen memory, we add 40 since the screen goes across 40 characters. Loop until all the tiles are drawn. Get the high bytes of our screen memory tiles while drawing down the screen. And here you see an example of the attribute word data that is being used to create those examples we saw earlier. And then now below here, you'll see this is all the map data. And I wrote the following table looks up map data. Low bytes loaded from CharPad used for tile screen drawing can be expanded or altered to fit your exact map screen size. And here's our high bytes. This is our tile data. So the table data for CharPad tile set binary data. And these are our high bytes. Summary of topics covered. In this video series, you learned how VIC-2 can only access 16K of memory at a time and requires banking memory to relocate areas that are more accessible to character set data, sprite data, and so on. Next, character ROM data was copied to RAM. Then tiles were placed in screen memory reading from CharPad binary file data. Thank you for watching. I want to personally thank you for watching this series, subscribing to this channel, subscribing to my Facebook page, and just being here today. It is people like you that help keep the Commodore 64 alive after all these years. Feel free to share this video with your friends, family, or anyone who finds it interesting to create their own game projects for the Commodore 64. Hi everybody, I want to thank you for having joined this series of the Commodore 64 game project. I'm looking forward to seeing the actual projects you come up with for your own designs. And I hope in this series that you learned about how to bank memory on the Commodore 64, relocate the ROM memory into RAM, which expands the graphics available for other things like character set sprites and so on. And also learning how to take CharPad data and get it onto the main screen. And yeah, this has been a great series. Stay tuned because it's getting better, because the next video we're going to learn how to scroll a map, and we're going to continue that progression as we go forward. So thanks for watching, guys. I appreciate all your subscriptions, and I look forward to meeting you guys on the Facebook page real soon. Take care.